Well, happy Monday or Tuesday, everyone, depending on what day you have me in class. Welcome to your last lesson of e learning. It's hard to believe that it has been 7 weeks, but it has. And we want to finish up strong with the unit circle. Um, both of my classes have taken a quizzes on the unit circle. We'll be very proficient at that. So we need for you to be able to fill in the unit circle in all areas. In other words, I need for you to be able to tell me what the degrees are and what the radians are of each section of this unit circle. For example, I need you to know that this is 0, this one's 30. Hold on, we're going to pause for a second. All right, sorry about that. Phone call. Angela, she said hello. At any rate, let me get back to this. So 0 degrees, 30 degrees, 45 degrees. How can we make this go away? Go away. Not that. That's so interesting. I don't know. Okay, we'll leave it alone then. I guess it wants to be here for today. 60 degrees, 90. Whoops, I wrote it on the wrong spot. Eraser. So I'm trying to do this appropriately here. So 90 degrees and all the way around. So what we're asking you to do is to be able to fill in the entire unit circle. So add 30, you're at 120. So you wouldn't have to put the degrees on it if you were taking this as an assessment for me. So 15 degrees, 135. That's why we've already written it. But what we would like for you to be able to do is to do this in 5 minutes. You're accelerated, so sometimes we like to get it down to 4 minutes, 3 minutes, and we really want you to be able to do this very well. 15 more degrees would put you at 150 degrees. So seems to be the hardest part for students sometimes. Anyway, this is how I would have taught you to do it in person. 180 degrees, and then you're adding 30, so you're at 210. Then you're adding 15 more, so you're at 225. Then you're adding 15 more, so you're at 240. Then we're at 90. So when we're at the 90 degrees, you've gone 90, 90, 90. So you're at 270. And then you're going in 30 more degrees. So you'll be at 300. 15 degrees more, 315. 15 degrees more, 330. And then we filled in every one of the angles around that one unit. Remember that the unit has a radius of 1. You can drop your reference triangles for every single one of these. And then you can go back and then put in your radians instead of degrees. So this is still going to be 0 radians if you're sitting at 0 degrees. Now, if you're at 30 degrees, you've gone 1/3 of the way of the 180 degrees. So 180 divided by 3 is going to be 1/6. So you are now at pi 6. So 1/6 pi, but we don't call it that. We call it pi 6. This one is 1/4 of the way, pi 4ths, and this one is 1/3 of the way, so pi 3rd. Then we're halfway at 90 degrees, so we're at pi halves. And then I have to just think about how many of these I have moved. So if I'm going from 60 degrees and then I've moved 30, 15. So the way that I like to think of it is then I actually, I remember that this is my 30 degree reference, this is my 45, and then this one is my 60 degree reference. So when I get ready to do the 60 degree reference, I know that this goes to 2/3 or 2 pi thirds. This one is 3/4, so 3 pi fourths, because you're 3/4 of the way. And then this one is 5 pi 6. So the 30 degrees, it's broken into 6 pieces because it takes 6 30s to make 180. So I've moved 5 out of the 6 if I've gone this far. And then I just keep thinking the rest of the way around the circle. So if I've made it to 180 degrees, I've made it to a pi. And this one, as I keep going, I'm at 1 and 1/6. So 1 and 1/6 pi is going to tell me that I'm at 7/6 pi. So, or 7 pi 6. And then I'm at 1 pi plus a quarter of another one. So 1 1/4 would be 5/4 pi, or 5 pi fourths. And then this is 1 1/3. So 1 1/3 would tell me it's 4 pi thirds. And the more you do this, the faster you can go at it. And so here I've gone 1 whole pi and half of another. So a whole pi and half of another is 1 1/2 pies, which we would call 3 pi halves, or 1 1/2 pies. And then as we start up the other side, you may want to start going down, or you may want to continue going up. It doesn't make any difference to me. So this is 1 5/6 pi, and 1 5/6 pi makes 11 pi 6. And this one is 1 3/4 pi, which will tell you you have 7 pi fourths. And then this one is 1 pi and 5/6 of another pi, or 4/3. So a third of another pi. So 1 whole pi plus 2/3 of another pi is going to tell me we're at 5 pi thirds. Or I'm sorry, I said that wrong. 1 whole pi and 2/3 of another. All right, so that's how I would fill all of these in. I memorized this first quadrant, and then the ordered pair are just we can zoom through these. So this one's 1 0, this one's 0 1, this is -1 0, this one is 0 -1. Those are the quadrantals. And then I'm going to zoom around and put in the ordered pair. I only really have to memorize 2. This one is √3/2 and 1/2. This one switches them, 1/2, √3/2. And this one is √2/2 and √2/2. And everything else around the entire circle is exactly the same, with the exceptions. You have to pay attention to where your coordinates are. So these are both positive. These are negative x, positive y's. Remember, they're always in the order cosine theta, sine of theta. So the things I have to remember are very basic, but if I can get those into my long-term memory, I can be very successful at this in my trig. Especially in my pre-calculus class, I have to know these basic trig facts. These are like multiplication tables in trigonometry. When you go into the other quadrants, you can do them any way you want. I like to start backwards most of the time. This one's √2/2, and this one's √2/2, and this one is the switched 1/2 and √3/2. Now remember, your x coordinates are negative. When I get down to my third quadrant, remember that you're negative. This one is still your 30-degree reference angle. So I'm going to go back and put them in. √3/2, 1/2, √2/2, √2/2. And this one is 1/2, √3/2. So you switch them. Then I have to remember where I am. Third quadrant would be -x, -y. So I have to go back and make everybody negative. Moving to the last one, I do the exact same thing all over again. √3/2, 1/2, √2/2, √2/2, and then 1/2, √3/2, positive x and negative y. So go back and make sure all of those are negative y coordinates. One final thing to make sure that you have added to your long term here. So let's say that we want to save these. We want to go to blue this time. Remember that you know that all of your trig functions are positive in the first quadrant. All students take calculus. That's your goal. So your sine and your cosecant. So sine and cosecant are positive in the second. Tan and cotan are positive in the third, and then your cosine and your secant are positive in the fourth. All right, so adding that to what you do is going to be very, very important. So please practice. Go to quizzes, go to Quizlet, do whatever you need to do to make sure that you can produce this unit circle, whether you're in degrees or in radians, in 5 minutes or less. Okay, so now that you have this unit circle at your disposal, I'm fine if you use it, because of our situation with e-learning. If we weren't, you would be required to know this. But there's just a couple of things that I need to finish up this unit with you. And number one is to be able to fill in that unit circle quickly. Number two, can you find now the 6 trigonometric functions for each of the following? And again, we would probably do this as a timed ratio, but at any rate, if I'm at 5 pi 6, I know that I'm at almost at a whole pi, but not quite. So I'm at 150 degrees. So they're going to ask me for the sine, cosine, tan, and then the cosecant, secant, cotan. So the sine of 5 pi 6, the cosine of 5 pi 6, and the tan of 5 pi 6. And so all I need to know is, well, what are those values? So if you're looking at 5 pi 6, you're looking at a 30-degree reference. Just make sure you remember your sines. So your sine of 5 pi 6 is a half. Your cosine is the negative root 3 over 2. And your tan then is a sine over a cosine. And if you do your simplification, you're going to find out that it's a negative root 3 over 3. Right, now that may take you a little bit of time to get that down a little quicker. And you may want to go around the unit circle and actually add in, well, what is the tan? And what is the tan? It may take you a little bit of time to go through and calculate those, but certainly not a problem to do that. So if you're going to tell me it's a root 3 over 3, you might as well memorize that as you go. When I get to the second 3, I need the cosecant, I need the secant, and then I need the cotan of 5 pi 6 and 5 pi 6. So what I need are the reciprocal of each one of those. So 1 over 2 is 2. A negative 2 over a root 3 is negative 2 root 3 over 3. And so I think that you're going to be able to rationalize these in your head eventually. That's our goal. And then the negative root 3 over 3 is the same thing as a negative root 3 if I go there. Those are the 6 trigonometric functions for each one. So then if they ask me to go to 5 pi thirds, so really this is just understanding the unit circle and being able to reproduce that. So if I go sine, cosine, and tan, and what we're looking for is 5 pi thirds. And 5 pi thirds is 1 2/3 of a pi. Oops. And then my cosecant, my secant, and my cotan of 5 pi 3, 5 pi 3. It's just a lot of writing. Ugh. Okay, so if I'm at 5 pi thirds, it means that I'm at 1 pi and 2/3 of another. So I have to know if I'm 2/3 of the way that 5 pi thirds, well where is 5 pi thirds? And if I'm looking for, well, 2/3 of another one would tell me I'm 60 degrees from being finished. So that means I'm here. I'm looking at a 300 degree or a 60 degree reference triangle in the 4th quadrant. So once I know where I'm located, then I can really easily produce all of these things that I need. So if I'm looking to produce them really quickly, this one's a negative 3 over 2. This one's a positive 1/2. And then the sine over the cosine, root 3 over 2 over 1/2 would tell me that it's a negative root 3. Whoops, a negative root 3. That left hand, always in the way. And then when I get ready to do their reciprocal functions, cosecant, a negative 2 root 3 over 3. The secant, reciprocal is a 2. And then your cotangent reciprocal is negative root 3 over 3. And then that's how I go through and find the 6 trigonometric functions using the unit circle. All right, next part. Can you find all of the values of t between 0 and 2 pi for which the cosine of whatever the angle is 1/2? Well, so I go back to my unit circle again, and I'm looking to see, well, where is my cosine of what angle? Where is it equal to a half? And so the places around my unit circle where I'm equal to, and please don't think that it's okay if I accidentally use a negative. It's not. So if I'm looking for the half, I'm looking for a 60 degree, and then I'm going to look, well, that one's the negative. So where is my cosine positive? Well, I know that it's positive at a 60 degree angle in the first quadrant. And then I know that it's also positive here. Sorry. It's also positive here in the fourth quadrant when you're at a 300 degree angle. Now, if you notice that they are asking you between 0 and 2 pi, then you cannot say it in degrees. So you cannot use degrees if they are asking you between 0 and 2 pi. You must use radians. Okay, so you can't switch and use them interchangeably. If they're asking you between 0 and 2 pi, then you have to use radians. If they're asking you between 0 and 360, then you use degree. So what I have to do is know what 60 degrees is in radians. So remember that that's 1/3 of a pi. So you're going to tell me it's at pi thirds. And if you're at 300 degrees, remember that you're 180. So, and you're 270 plus 30 more. So you're at 1 2/3 pi. So you're at a 5 pi thirds. So, and it could be more depending on what they ask, but they're only asking you what angle is between 0 and 2 pi will give you a cosine of 1/2. All right, and then finally, the last thing that we need to look at are even and odd functions. So even and odd functions, if you remember from algebra, when you were in Excel Algebra 2, the definition for which f of negative x is equal to f of x for all x in the domain of x, if you have an even function, is a function for which replacing the x with its opposite, it leaves the equation that defines the function unchanged. So if I put a negative in place of my x, it's going to kick back out to me the exact same thing I started with. In other words, the even functions do not change the value of my original function. That's why it's called an even function. If a function is even, then every time the point xy is on the graph, so is the point negative x positive y, because it does not change the output just because I put in a negative x value. So if I were to check this, in algebra, what we would do is we would put a negative x in place of my positive x and see if that changes the value of my f of x function. Well, negative x squared gives me a positive x squared plus 3. So because this value is unchanged from my original value, it is unchanged. Therefore, this is said to be an even function. So this is an even function. The same thing is going to be true with our trigonometric values as well. An odd function, on the other hand, for which f of negative x is the opposite of the f of x for all x in the domain. An odd function is a function for which when you replace x with its opposite, it changes the sign of the equation that defines the function. If a function is odd, then every time the point xy is on the graph, so is the point negative x, negative y. In other words, it's going to change every sign inside of there. So the function then happens to be odd. For example, if you are going to put a negative x here, I have a negative x cubed and then minus a negative x. Well, a negative x cubed is still a negative x cubed, but minus the negative changes this to plus a positive. So because the signs are reversed when I put in a negative value, this becomes what's called an odd function. So in our unit circle, we can determine whether sine and cosine are even or odd as well. So if I have a sine function, and I'm just going to pick an easy value. So if I have the sine, and we'll pick something easy. Let's just pick the first one, pi 6. Well, the value of the sine of pi 6 is a positive 1/2. So then what I need to do is check the sine of a negative pi 6. And the sine of a negative pi 6 tells me that if I have a negative pi 6, then I have a negative 1/2 value. So since those values have changed to opposites, we are going to decide that the sine function is odd. The cosine function, if I take the exact same value, so let's say this time I'm going to use the cosine of pi 6, and the cosine of pi 6 is equal to square root of 3 over 2. And then I need to check its negative value. And if I check the negative pi 6, I also get a negative root 3 over 2. So because when I have inserted the opposite value and it has changed it from what it was to its opposite sign, therefore I know that this one, I'm sorry, that's not true. So if I go negative pi 6, positive side pi 6, so if I go a positive pi 6 and the negative pi 6, what I have, it's positive. I was going to say that doesn't make sense. It did not change the value of the sign. So if I go to the negative pi 6, so the negative pi 6, remember, would be down here. And my cosine, which is my first value, would be the positive. If I go to cosine here, it's also positive. So I have positive, positive, which is going to make this an even function. Okay, so now that we've determined that the sine function is odd and the cosine function is even, can we use this information, the even and odd function relationship, to find the exact value of each of the following? So if I go to the sine of the negative 60 degrees, then what I know is that it's the opposite of whatever the sine of 60 degrees is. And the sine of 60 degrees is root 3 over 2. So if I go to this, and if you wanted to go back and look at your unit circle, so here's my unit circle. So my cosine sine is root 3 over 2. So if I go back to my root 3 over 2, that's its value. Since this is an odd function, remember that it's going to have to be its opposite value at negative root 3 over 2. The cosecant is a little bit trickier because it's one of my inverse functions. So what I need to know is what is the opposite. So it's a cosecant of 1 over the sine. So the cosecant is 1 over the sine of 225. Uh-oh, left-hand drag again. So this one's in degrees, so I've got to be able to get to the sine of a 225, and it's got to be 1 over, so the reciprocal function. So that's going to tell me it's 1 over the square root of 2, or which is going to tell me it's the square root of 2. And once I find out that it's a negative square root, so this one happens to be the negative. So this one is square root of 2 over 2, and it's a negative. So because the cosecant comes from sine, it means that whatever this opposite was has to now be changed to its opposite as well, which means that this is going to be the positive square root of 2. The last one is the cosine of a negative 2 pi thirds. So since we said that the cosine angle is an even function, it will remain the same. So when I do the cosine of a negative 2 pi thirds, the cosine of this, the cosine of a 2 pi thirds is going to give me the same value. So the value of cosine of negative 2 pi thirds is a negative 1/2. So since it's an even function, it's going to remain the same value at negative 1/2. And those are the values for even and odd functions. Now we're going to stop. Unfortunately, we're not going to get to arc length and area of a sector, although we did that in geometry. You can do it a little bit faster with trigonometry, but unfortunately, that is going to be the end of our lesson on trigonometry. So your assignment, and if you'd like, let me zoom down here to the bottom of our assignment, and I can show you where it is. So we've missed a lot of these radian measures with our identities. So I'm very sad about that, but according to our situation right now, there's not a whole lot we can do. There is a review here if you'd like to take a little bit of time and make sure that you know how to do these sine, cosine, tans. The answers are right behind it, so if you want to try that, you're just interested in making sure that you understand this trig, please feel free to go ahead and do that. I'm going to scroll down to your last homework assignment. So your last homework assignment is going to come out of 3.3. So I know they're kind of weird in this packet. I apologize for that, but I'm really happy that I had this packet done. So there was 3.1. This was your Wednesday, Thursday assignment. And then we're going to come up on 3.3. So here's 3.3. So there is work that goes along. There's some notes and things that go along with 3.3. And then your homework for 3.3 is going to come here. So this is your Monday, Tuesday homework, section 3.3. And let me tell you what your assignment is, just to make sure that that's all done, squared away, and you are finished with your trigonometry class as we know it, at least for this year. Sorry about that, but you guys, it's been fun. You guys are an awesome class. So section 3.3, we're going to do 1 through 45, the odd ones, if it has decided it is done writing 1 through 45 odd. I love it, the way it's letting me write a 4 and a 5 odd. Okay, third time's the charm here. All right, so 1 through 45 odd. So you'll make it to right here. Okay, and that's your last homework assignment of this particular trig course. I will put the assessment up for you. It'll probably be an Alex for your final assessment coming up on Wednesday and Thursday. Okay, I hope you guys have a great day, and I'll see you soon.